Hello everyone and welcome. Today we're going to be looking at Lewis structures and VSEPR. Okay. Now this is going to be a good lesson to especially to prepare you for grade 12, as you'll be seeing this in grade 12 as well. So what we're going to be doing today, we're going to be drawing structures. Okay, molecular compound structures. Okay, so those are with non-metals. And what we're going to be doing, we're going to be adding a couple things to our drawings, and once again, we'll kind of look at it as we go along. Okay, now if you take a look down here, there's some rules for drawing your Lewis structures. Now, when it comes to those rules, you can go ahead and try and memorize them. However, I don't recommend that. I would recommend you just knowing how to draw, and the more practice you do, the better you will get at this. Okay, so let's jump right on in so we can get a better idea of what we're dealing with here. All right, so we're going to start with H2O. We're going to start with water, and we're going to look at how to draw these compounds. Okay, so the first thing that we're going to do is we're going to draw our Lewis diagram, okay, or our Lewis structure. So our Lewis structure, what we need to do is we need to figure out which out of these two molecules is our central atom. Okay, now in grade 11, okay, we're going to be looking at having one central atom and then everything being connected to that central atom or that middle atom. So the way that you can tell which one's your central atom is 99% of the time it's the one that you have less of. So if you take a look at H2O, we have 2 hydrogens and only 1 oxygen. So the one that we have less of, that's going to be your middle or central atom. So I only have 1 oxygen, so that's going to be my central atom. And what I do is I start off by drawing oxygen as a Lewis structure. So oxygen has 6 electrons. 1, 2, 3, 4, 5, 6. Okay. Now, we need to fit in 2 hydrogens. So what we're going to do is we're going to take a look at this compound. Where are there openings to fit this hydrogen? Well, if you take a look, these 2 electrons are happy by themselves. These 2 electrons are happy by themselves. But these 2 have some openings. So what I'm going to do is I'm going to draw 1 hydrogen. Okay, and once again, hydrogen has 1 electron in its valence shell there. And I'm going to draw 1 hydrogen with its valence electron there. Now, what do we remember from our molecular compounds is that they like to share electrons. Okay, there's no transferring. So what's going to happen is that they're going to form a bond. They're going to share these 2 electrons. And now we have hydrogen connected to our central atom. And we need to do the same thing over here. Okay, so that's our Lewis structure diagram. The next one we want to do is we want to fix this up, we want to clean it up, and we want to make this into our 3D sketch. So our 3D sketch is going to be essentially, okay, we're just cleaning it up. Okay, so we have 1 oxygen connected to hydrogen here. And another connection over here. There shouldn't be touching there. Okay, but anyways, I have oxygen connected to 1 hydrogen connected to the other. And then you need to fill in your electrons. So there's 2 at the top and 2 at the bottom. And that's what we have here. Now, some people will ask, why don't you draw water like this? Where can I fit this in? Maybe at the top. Okay, they say, why don't you fit it like this? Hydrogen bonded to oxygen to another hydrogen, and then you have your electrons there. Okay, so if you take a look at the structure, it's similar, right? There's 2 bonds to each hydrogen. There's 2 sets of electrons. It looks the same, but the problem is water doesn't look like this. It's not linear. It's not a line. It's more of a bent shape. Okay, so this would actually be incorrect. Now you might say, how would I know to draw this? Well, once again, if you go in order, okay, so when you're doing your oxygen originally, you went 1, 2, 3, 4 for your electrons, 5, 6, right? If you don't go in that proper order, your diagrams are going to be a little bit off. Okay, so you always want to make sure that you do that there. Now, Before we move on to the next one, okay, this is what H2O would look like. We're going to introduce a new concept, okay? And this new concept is called lone pairs and bond pairs. Okay, now the formal definitions you can find in your textbook, okay, as well as if you look at the filled lesson online, I have it there, but I'll talk about it here in the video. So your lone pairs are electrons that are not involved with bonding. Okay, typically when you're drawing your structures, you're going to see this. You're going to have those two dots. That's what we call our lone pairs of electrons. Now, our bond pairs are electrons that are involved with bonding. In our structures, they're going to look something like this. They're going to have that dash. Okay, so what do I mean by that? Let's look at our drawing here. Okay, what we need to look at is we need to look at the central atom. So the central atom is just oxygen. So I'm going to cover up my hydrogens. Now, how many electrons do we have in this valence shell? We have 8. We have 1, 2, 3, 4. Okay, remember this bond here is 2 electrons. There's 2 electrons in there. 5, 6, 7, 8. Okay, now out of these 8 electrons, and once again, we're only looking at the central atom, which ones are lone pairs? Which electrons have nothing to do with bonding? Well, these 2 at the top and these 2 at the bottom. Okay, and once again, they look like that. That's why I put that little drawing, the 2 dots. So what we say is that our lone pairs, how many pairs do we have of this? Okay, and you should remember that electrons like to stay in pairs. They like to stay in 2. So we have 2 pairs of electrons. 1 pair over here, the second pair over there. What about, I'm going to do a different color here. What about our bond pairs? How many pairs do we have here? Well, we're going to have 1 pair there, and we're going to have a second pair there. Now, you don't have to draw the 1 and the 2s. I'm just doing that because it's our first time doing this. So we also have 2 pairs of bond pairs. Now, how many electrons is that? Well, 2 plus 2, that's 4 pairs. 4 times 2, that's 8 electrons. And that's how many electrons we have in this valence shell here. Okay. So what I want you guys to do, okay, is I want you to try this next drawing underneath. Carbon tetrachloride. See if you can draw what it would look like. Okay, and then after that, see if you can figure out how many lone pairs, how many bond pairs we have. All right, so for carbon tetrachloride, what we're going to start off doing is we need to figure out which one's our central atom. So which one do we have less of? Okay, now once again, I have 1 carbon, I have 4 chlorines. So I only have 1 carbon, that's the less that I have. So I'm going to start off by drawing carbon. 1, 2, 3, 4. Now, once again, as you'll notice, okay, these ones are a little bit simpler. We're going to get a little bit more complex later on with our drawings. But once again, it's good to get the foundations down. So if I have 4 carbons all the way around, or 4 electrons, where do you think your 4 chlorines are going to go? Well, they're going to go all the way around. So I'm going to start off by drawing a chlorine at the top. Okay, now once again, how many valence electrons does chlorine have? It has 7. So 1, 2, 3, 4, 5, 6, 7. This one here has 1, 2, 3, 4, 5, 6, 7. This one here has 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, every single one of these outer electrons needs to be attached to the central atom. So, what we're going to do, once again, because there's 2 nonmetals, okay, they're going to be forming a covalent compound. So they're going to share their electrons. So there's 1 here that chlorine's willing to share, 1 there that carbon's willing to share. So these are going to make a bond there. There's going to be a bond between these 2. there's going to be a bond between these two. And this one's not going to look so nice because we have to go all the way around. But you get the idea. There's going to be a bond going from this one to this chlorine here. Okay, so that's kind of our rough Lewis diagram sketch. We're going to draw another one here. Okay, so once again, we're going to start off with carbon in the middle. Now we're going to have 4 chlorines all the way around, and they're all bonded. So I'm going to draw it like this. Chlorine to chlorine to chlorine and to chlorine. So they're all the way around. The next thing is we need to make sure we have our electrons there, right? Each chlorine has 6 other electrons on the outside, so we need to draw those in. We didn't have to do in the previous one because hydrogen's only okay with 2. So we didn't have to draw 8 of them around. Hydrogen and helium are the only ones that are okay with 2. So anyways, let's go with chlorine. So we need 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, how you can always check your work is by making sure you have 8 electrons for every single one. Now, once again, the exception would be typically hydrogen. Okay, yes, helium is 2, but helium is a noble gas, so it doesn't like to bond with anything. So let's take a look at carbon first. That's our central atom. I have 1, 2. Okay, once again, each of those dashes are 2. So 1, 2, 3, 4, 5, 6, 7, 8. Carbon is happy. What about this chlorine over here, let's say, on the left side? Okay, it's going to have 1, 2, 3, 4, 5, 6, and then 7, 8. And it's the same all the way around, so everything's happy and it satisfies that octet rule. So that would be a proper drawing here. Now, the next thing, okay, we're going to draw our lone pairs. Now, you can write lone pairs like that and bond pairs like this. Okay, if you do, I'll know what you mean by that. So let's take a look. Now, once again, we're only looking at the central atom. So we do not worry about the chlorines on the outside. We are just looking at the carbon. Okay. Now, how many lone pairs do you see? How many of those lone electron dots do you see? Okay, now once again, we're not looking at the chlorines. Okay, I don't see any in there. So I'm going to put 0. How many bond pairs? I have 1, 2, 3, 4. So 4 bond pairs. Now, once again, 4 pairs means you have 8 electrons. 4 times 2, right? A pair is 2. So that makes sense because, once again, I have 8 electrons in that outer shell there. All right. Now, the next part to this lesson that we're going to be looking at is we're going to look at our VSEPR geometries. Now, in order to do this, you're going to need to pull out the formula sheet, the data handbook formula sheet package that I have online. Okay, and if you go to, I believe it's the last page of it. Okay, and I have something here. It's called VSEPR geometries. Now, what the VSEPR geometry tells us is what shape our compound is. Okay? So this is only some of the shapes that we could see. In grade 12, you'll see more. And if you take post-secondary chemistry, you'll see even more after that. Okay? So what we're going to do is we're going to try and figure out how we can figure out what type of shape we have here. All right? So let's look at the first one. Let's look at H2O. Now, in order to do this, you need to match, essentially, what the shape that you drew to what you have here. Okay? Now, before I actually get into it, I want to explain a couple things in this drawing here, okay, or this diagram so you can see. At the top, we have our lone pairs. So something that has 0 lone pairs could look like any one of these 3. If you have 1 lone pair, it could look like any of these 2. If you have 2 lone pairs, there's only one option for grade 11 anyways. And if you have 3 lone pairs, once again, only one option that we have. Now, you'll see a couple things, okay? Take a look at this one here. In all the drawings, you'll have a central atom. The central atom is denoted with an E in these drawings. So this one has a central atom, all throughout. Then you'll see that you have X's on the outside. Those are the atoms on the outer perimeter. So this one has one central atom and two atoms on the outside. This one has one central atom and three, one central atom and four, one central atom and two, okay, and so forth. Now, if you take a look at this one has one central atom, two outer atoms, and then it has one pair of electrons. That's what that is right there. This one here has one central atom, three outer atoms, and then one pair of electrons. This one here has two outer atoms, and it has two sets of electrons, and so forth. Okay? You'll also notice that there are degree signs. Okay? Now, once again, we're not going to be worrying about those angles this year. However, just so that you guys do know, if you had this shape here, these two outer atoms are 180 degrees from each other. These three atoms are all 120 degrees from each other. Okay, 120 times 3 gives you 360. Okay, this one here has 109. Okay, these ones are 109. These ones are 120, and so forth. Okay. The last thing I'm going to point out is that you could have these lines. Okay, so you'll see that some of these outer electrons, so the dashes look different. So these ones are straight. Okay, see these lines there. But let's look at this one back here. So you have two of these outer atoms that have these bonds that look like this, and then you have two bonds that look like that. Okay, these ones look different. These ones look different, right? You have those. So what does that mean? Now, what that means is that this is a 3D sketch. Okay, you have to think of an atom or a molecule, not linear or 2D like this. You need to think of it as 3D. So one of these atoms is actually coming out of the page, and the other one is going into the page. And that's how you get that 3D. Okay, so you have two of them on your X and Y axis, and then you have two of them on your Z axis. So that's your coming out of the plane and into the plane. Now, it's a little bit tricky to kind of think about, especially learning it for the first time. But if you go online and look at some of these, they'll have some 3D sketches for you, and it's a lot kind of easier to see. So let's go ahead and let's try an example. Let's learn how to use this, okay? So let's go back to our H2O example. Okay, so in our H2O example, the first thing you're gonna do is you're gonna draw your compound. Then you're gonna tell me how many lone pairs, how many bond pairs, and we already did this. So now we're gonna try to figure out what is our VSEPR, VSEPR. What structure do we have here? Okay. So for our VSEPR structure, what we need to look at is we need to look at our lone pairs. So our lone pairs are 2. So let's go at the top. So 0 lone pairs, no. 1 lone pair, no. 2 lone pairs, well, there's only one option. So we get a bent or angular structure. Now, before we even write that down, let's make sure that our structure looks the same here. So in our structure, we have one central atom. We have 2 outer atoms, and then we have 2 sets of electrons. So this one here, I have 1 central atom, I have 2 outer atoms, and I have 2 sets of electrons. So this shape looks the same as that. So we say that this structure is bent or angular. Now, the next thing I'll ask you, is this symmetrical? I'm just going to put SYM, or non-symmetrical. Now, if you take a look at your sheet here, I've actually inputted them in myself. So see here, this shape is symmetrical. This shape over here is symmetrical. This one's symmetrical. This one's symmetrical. These 4 are symmetrical, and these 4 are non-symmetrical. So this one is non-symmetrical, so that's what we would have here. So this structure is labeled as bent or angular and is a non-symmetrical structure. Let's look at the next one. Okay, I'm going to try and get this all in here. Okay, I don't need that structure. I need this structure here. So I'm going to kind of pull over. All right, so let's look at this next one here. So we're trying to figure out the shape. So the first thing we need to do is we need to look at how many lone pairs we have, because that's where that kind of tells us. So in this case, we have 0 lone pairs. Now, in this time, we have 3 options. So we need to be kind of careful of what we're picking. So in this structure, I have 1 central atom and I have 4 outer ones. So which one would that correspond to? Well, this one has 1 central and 2, so it can't be that. This one has 1 central and 3. This one has 1 central and 4. So it has to be this one here. So our structure, VSEPR, okay, so our VSEPR structure, this one here is what we call tetrahedral. Now, is this symmetrical or non-symmetrical? Well, looking at here, I see it says symmetrical, so that's my answer there. Okay, so that's how we introduce, or that's how we do our VSEPR structures geometries on this. So what I'm going to ask you guys to do is let's try the next one. Okay, I want you to try the next one. See if you can do it completely. Okay, see if you can draw this. Figure out your lone pairs, bond pairs, what type of structure you have. Is this symmetrical or non-symmetrical? All right, so for this one here, we have phosphorus trihydride. So the first thing we're going to need to do, we're going to need to draw the structure. So my central atom is my phosphorus. Phosphorus has 5, 1, 2, 3, 4, 5. And I need to fit 3 hydrogens. So there's 3 openings here. There's 3 bond pair electrons. So I'm going to put 1 over here, 1 at the bottom, and 1 over there. Now I know that I need to make my bond. So I'm going to have 1 here, 1 here, and 1 there. Now, before I move on, is everything satisfied? Well, my hydrogens have 2, so those are all happy. My phosphorus should have 8. I got 1, 2 at the top, 3, 4, 5, 6, 7, 8. So everything is satisfied, and now I can draw my structure here. So I have P to 1 hydrogen, to a second, to a third, and I have those 2 lone electrons at the top. Next, let's look at my lone pairs, bond pairs. Now, once again, you're only looking at the central, the middle atom. So in this one here, I have 1 set of lone, and I got 3 sets of bond pairs. Once again, that equals 4. Now, you may see in some other examples that sometimes they don't add up to that. Okay, and we'll see this later on in another lesson later. Okay, but for now, they should equal 4. Next, we have our VSEPR. Okay, so what structure do we have? So once again, if I'm pulling out my structure sheet here, okay, I have 1 lone pair, 3 bond pairs. So I have 1 by itself, and then I have 3 around, and then I have 1 set of electrons. So it has to be this one here, and this one's called trigonal pyramid. Now, is this symmetrical or non-symmetrical? So once again, if I'm looking at the sheet, there's a non-symmetrical right there. So this here is non-symmetrical. And that's what we have here. All right, we're going to try one last one. Okay, Cn. Okay, and it's 1 negative. That's a 1 negative charge. This is called cyanide. It's a polyatomic ion. So it should have 1 negative on the outside there. Okay, not -1, I should say 1 negative. Okay, now try this one out. This one does not fit the rest. Okay, this one's an exception. Okay, so try it out, and when you're ready, resume the video to see if you got it correct or not. All right. So for cyanide here, we have one carbon, one nitrogen. Which one's my central atom? Well, I only have 1 and 1. So what that means is that I have, and I'm going to kind of draw something out. I have one thing here. Okay, let's just pretend that's one atom. And I have another thing there. So I don't have a central atom. What I'm realistically going to have is I'm just going to have a bond between two. It's almost like an ionic compound, but not quite. Okay, so I only have two things. So what I'm going to do is I'm going to draw carbon first. Carbon has 4. Nitrogen has 5. So we need to bond these two. These two need to be together. Okay, so I see 1 here and 1 there. So these two can come together. Now, can I make more bonds? Because I see that carbon here isn't happy. Neither is nitrogen. So can I add more bonds? Well, yeah, I can. I see 1 here. These 2 electrons could share each other. And this one's not going to look so nice, but there's 2 electrons on the outside as well. These can share as well. Now, because we have 3 bonds going between each other, we have something that we call a triple bond. So I'm going to have carbon, 1, 2, 3, to nitrogen there. Okay, I need 2 electrons on my nitrogen, and I need 1 electron on my carbon. Now, before I move on, are both of these atoms happy? Well, let's look at the nitrogen first. So I'm going to cover up my carbon. So I have 1, 2 at the top, 3, 4 in this bond, 5, 6, 7, 8. So nitrogen's happy. What about carbon? I got 1, and then I have 2, 3, 4, 5, 6, 7. So this one only has 7. So it's not happy. So what can I do? Well, if I try to make another bond here, well, that's not going to work out because then I'll have too many electrons for nitrogen. Well, what I could do is right here, this 1 negative. What does 1 negative mean? 1 negative means that I add an electron, right? 1 positive means I lost an electron. So where do you think I can add this last electron? Yeah, if you thought right on top of the carbon with that one, you'd be correct. Okay. Now, sometimes you may see me put like an X there to show that's where my electron went. You could also put a dot there. Both of them are fine. Okay. If you want to put an X or a dot, both are okay. Now, there's only one other thing that we need to do. Because we added an electron, this is now a polyatomic ion. How do we draw ions? We need to put our square brackets, and we need to put the charge. So you could draw it like this, or you could draw it like this. Both are fine with me. Carbon, triple bond, 2 electrons, but you always need that there. All right. Our next question, lone pairs, bond pairs. Now, in order to do lone pairs and bond pairs, I need a central atom. Do I have a central atom? No, I don't. So, unfortunately, I can't do this. I don't have lone pairs, bond pairs, because I don't have a central atom. But, can I figure out what my structure is, my VSEPR? Well, I don't know. Let's take a look. Is there anything in here that maybe looks the same? And once again, what you're looking for is we have 2 things connected together. Okay, so if I look here, I got 1 central, 2 outers, 1 central, 3. Same thing, 1 central, 2, 1 central, 3, 1 central with 2. This one I have 1 central with 1. So what does that mean? Well, this means like I have two things connected together. And that's kind of what I have. Not the exact same, but similar. I have one thing connected to one other thing. Now, what's the shape that it's saying? It's saying that it's linear. All right, well, does that make sense to us? I'm not sure. Well, let's think about it. This is where I drew this. Those are my two atoms. Here's my carbon, let's say. Here's my nitrogen. What is the fastest way between 2 points? Or what is the only way that you can draw a line between two things? Well, you draw it linearly, right? If I had carbon and I had nitrogen here, I'm not going to draw it like a triangle. No, right? I'm going to draw it straight across. So how we connect two things together is only linear. It's a line connecting one point to the next. So that's what our structure is. Now, the last one, symmetrical or non-symmetrical? Well, over here it says non-symmetrical, and that is correct. But once again, let's think about that logically. Okay, if you were to split this down the middle, now you don't have to draw this, I'm just trying to show. If I were to split this down the middle, whatever's on one side, is that the same on the other? Well, you might say yes. You're like, oh, well, look, I have 3 bonds. They both have 2 or 1 lone pair each. Yeah, you're right like that. However, look at your atoms. Your atoms are not the same. So this is not symmetrical. So that's why we have non-symmetrical here. Okay? If they were both nitrogens on both sides or both carbons, then that would be symmetrical. But because we have 2 different atoms, that would be classified as non-symmetrical there. So this one's a little bit different than the rest, okay? 90% or 95% of the questions we're going to be dealing with something like this with one central, a bunch around, but you may see some of these along the way, okay? And these ones are pretty good because they make you think a little bit deeper. Okay, well, thank you for watching. Hopefully this made sense to you, and have a great day.